So we have this equation x square minus 7x, 7 of integer part of x or greatest integer function of x plus 5 equal to 0. And we want to find the sum of the squares of the roots of this equation. It's a very curious looking equation, and we already in the last video said that take this part to the right hand side. So 7 box of x minus 5. Recall that every number can be written as a sum of integer part and fraction part. So this is integer part and this is fraction part. So we assume that the fraction part is always greater than or equal to 0. For example, even if we have a negative number, we make the integer part negative and the fraction part positive. That's a convention. Okay, so let's rewrite this particular expression in that form. So I plus f whole square is equal to 7 times the integer part minus 5. Now, quick note that I must be positive. Why? Well, firstly, the left hand side is positive, right? It's a perfect square, so the left hand side is definitely greater than 0, greater than or equal to 0, which means that the right hand side must be greater than or equal to 0, right? So 7 times I minus 5 is greater than or equal to 0, which means that I is greater than or equal to 5 over 7, which means I has to be a positive number, a positive integer. So at once we know that whatever number will satisfy this equation here, its integer part has to be positive, which definitely means that its fraction part is definitely positive by the convention that we mentioned. So positive plus positive means x has to be positive. So any number that might satisfy this equation, if such numbers exist, they need to be positive. Okay, so this is a very important advancement toward this problem, that we found that the integer part or the number itself must be positive. Okay, now let's proceed a little bit more. You can pause the video here and try the problem a little bit more yourself if you want. Okay, so the next thing is we look at the growth rate. You see, this is a very powerful problem solving strategy. The point of these videos are not only solutions to problems, it is also to learn and explain how problem solving strategies work in general, so that you can apply them in other problems. So what is this growth rate? What is this strategy of growth rate? You see, the left hand side, which is I plus f whole square, the left hand side is a quadratic in I. This is a quadratic in I, the integer, right? Whereas the right hand side is 7i minus 5, which is a linear function in I. You see, this is not possible forever. For example, forever in the sense for all integers except maybe some, this is not possible. Why? Because these linear functions, the intuition is this, that this linear function is slow and a quadratic is fast. So after maybe some number of integers, the left hand side will overtake the right hand side. So what is the bottom line? Bottom line is, it won't work for most integers. Maybe it will work for some small integers, that might happen, but for most integers, for larger values, it will fail as I gets larger. This is the intuition, and this is also a problem solving strategy, that whenever you are solving these weird kind of problems, look at the growth rate of the things in both parts, both sides. That will be your hint. So what we understand is that the left hand side will overtake the right hand side eventually. So what we really want is to test with those few values where the left hand side is equal to the right hand side. So you see the left hand side is is greater than or equal to I square, right? Because there are some extra stuff here. So it's certainly greater than or equal to just I square. And therefore the right hand side, which is equal to the left hand side, must be greater than or equal to I square. So we have this 7i minus 5 being greater than or equal to I square. So you have an inequality, 7i minus 5 is greater than or equal to I square. This is quadratic and the left hand side is linear. So this cannot happen forever. It might happen for some smaller numbers. So this is the second hint, end of second hint. Try using this hint and see if you can find out those few integers for which this inequality actually holds. And maybe using those few integers, you can find those x squares for which this particular equation has a solution. Give it a try, and link in the description will take you to the next video. And keep on doing great mathematics. All the best. Bye.